أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم.
Running, interpreting and reporting one-way ANOVA. So what is one-way ANOVA? Now we have seen that independent sample t-test is actually used to compare differences in the sample that has two different groups. Now there may be a situation when you want to compare for a particular value among more than two groups, or when you want to make comparison in three or more than three different groups. Now in that case, you cannot use independent samples t-test because there are more than two groups. In such a situation, you will have to use one-way analysis of variance. Now one-way ANOVA is also referred to as one-way between groups ANOVA because you will have one independent, that is your grouping variable, with three or more levels, that is your grouping level will have three or more levels. In independent sample t-test, we had the grouping variable called gender. Now in this case, you will have a grouping variable with three or more levels. Gender had only two levels and one dependent continuous variable. In the simplest of words, one-way ANOVA is used to compare scores of three or more than three groups. For example, let's say marks. Let's assume I'm teaching three sections for the same subject. Now I want to compare the marks between those three sections. For example, I want to compare all the sections together with each other. So in that case, I can use one-way ANOVA. Now following are the few scenarios in which you would consider using one-way ANOVA. Now these are a few examples that will require you to use one-way analysis of variance. For example, an economist would like to know if there are differences in income. So differences in a particular variable, that is income, of lecturers, that is across the cities of London, Paris and Islamabad. So here your categorical variable is cities, or the grouping variable is cities, and there are three categories in the group, that is London, Paris and Islamabad. Another example, are there differences in optimism score? Now you are looking at the differences in a particular variable. Now these differences are compared across three different age levels. Another example, are there any differences in staff satisfaction? Now differences in a particular variable. Now this differences in a particular variable is your dependent variable. So staff satisfaction, optimism, income, all these are your dependent variable because you are evaluating the differences in these variables. You are interested in assessing the differences in these variables because of the factoring or the categorical or the grouping variable. In the first case, the grouping variable is cities. In the second case, the grouping variable is age. In the third case, the grouping variable is type of employment, permanent, part-time and casual. Now moving on, what's the procedure that we are going to employ to run ANOVA? Now ANOVA analysis uses the F statistic, which tests if the means of the groups, because obviously we are comparing the means in each groups with each other, formed by one independent variable or a combination of independent variables, are significantly different. Because what we are doing is we are comparing means, whether the average spending of group 1, group 2, group 3 is different or not. Or maybe the example, for example, let's say income of lecturers. So whether the average income of lecturers in London, Paris and Islamabad is significantly different from each other. So what you are doing is, since you are collecting data not just from one person, from multiple people, that's why you are taking mean. The reason that we keep on saying that you are comparing means is because you do not have any single value in particular group. In a particular group, you have data from maybe 30, 40, 50, 60 or 100 respondents. So how do you compare them? You take mean, average. You average from each group and then you compare those averages. That's why we keep saying that you are comparing averages from each group. The larger the F ratio, the greater is the difference between groups as compared within group differences. So the between group differences would be higher if the F statistic is higher. An F ratio equal to or less than 1 indicates that there are no significant differences between groups and the null hypothesis is correct. Now this is the criteria that you use to assess whether or not there are significant differences in a particular variable across different groups. If the null hypothesis that the group means do not differ significantly is correct, then we can conclude that the independent variables did not have an effect on the dependent variable. That is, the categorization did not affect the dependent variable. So whenever you are using one-way ANOVA independent sample t-test, the variable in which you are assessing the differences in is your dependent variable. The categorical variable with 2 or 3 categories is your independent variable. However, if the F test proves the null hypothesis to be wrong, that is, you reject your null hypothesis, the multiple comparison tests are used to further explore the specific relationship among different groups. Now, what do we mean by this? For example, if you reject your null hypothesis that yes, there are significant differences between different groups. Now you have to compare each of those individual groups between each other. The group A will be compared with group B, group A with C and B with C as well. So there will be multiple comparisons. Now what are main effects? Main effect is the direct effect of a single factor or independent variable on the dependent variable. It simply compares the mean of one level of factor with other levels of that factor. That is your multiple comparison with each of the categorical factor with the other factor. ANOVA designs are sometimes classified depending on the number of factors. Thus, one-way ANOVA includes a single factor which gives rise to single main effect. So there is a main effect, that is overall, whether or not overall there are significant differences or not. But then you need to have assessment of individual effects as well. The individual level and its effect on the dependent variable are further compared. Post-hoc multiple comparisons. Now, if your null hypothesis is rejected, so rejection of null hypothesis in ANOVA only tells us that overall the population means are not equal. So overall there are significant differences. Overall, yes, there are significant differences in the salary across the 3 cities. But we need multiple comparisons to find out whether there are differences in between, let's say, Paris and Islamabad, whether or not there are differences between Paris and London or London and Islamabad. Now these are individual comparisons that shall be made once you reject your null hypothesis. That is, the main effects or overall effects are significant. Now many tests are listed under post-hoc comparison. The most commonly used are LSD, Tucky, HSD, that is honestly significant difference. These are the most commonly used tests. Now how do we run this test in SPSS? First of all, I'm going to briefly give you the example. So a researcher would like to investigate organizational commitment and whether or not it differs between different job ranks. Job ranks are junior, middle and senior. So there are 3 job ranks and you want to assess whether organizational commitment differs across these 3 job ranks or not. So organizational commitment is your dependent variable and job ranks are your independent variable with 3 levels: junior, middle or senior, or 3 categories, or the factor with 3 groups. That is your grouping variable. So your hypothesis in this case is H0. The organizational commitment of the bank employees is the same in all the job ranks. So whatever the rank is, the job or organizational commitment will not change. Your alternate hypothesis is that there are significant differences in organizational commitment of the bank employees across the job ranks. Now, as the job rank changes, the level of commitment changes. So, your organizational commitment is dependent on your job rank. So, your organizational commitment is your dependent variable and job rank is your independent variable. Now we will also explain multiple comparisons. Now this hypothesis here, H1 or H0, this is the overall hypothesis or the main effects, the general comparison of organizational commitment across all job ranks. Now what if this hypothesis is significant and I want to inquire whether this organizational commitment, it actually differs between these groups. For example, it differs between junior and middle, junior and senior, or middle and senior. For this, I will need specific multiple comparison hypothesis. So these are my specific hypotheses, H02, H03, H04. Now this is null hypothesis, or these are null hypotheses. You can simply change them into alternate based on this H1. Please note the differences between H01, H02, H03 and H04. The F statistics obtained from ANOVA only tells us whether there is a significant difference in the mean values of the 3 groups, which is our H01. But in order to have individual comparison, you need these 3 hypotheses. Now from H01, we cannot conclude anything about specific hypothesis, that is your H02, H03 and H04. The later 3 hypotheses can be tested using multiple comparison tests, which have been explained in the later section. So what are the assumptions? As with all the tests, we've got assumptions as well. So what are the assumptions for one-way ANOVA? Number 1, your dependent variable must be measured on interval or ratio scale. That is, it should be numerical. In this case, the dependent variable organizational commitment was measured using 6 items. Each item was measured on a Likert scale. So we transform the 6 items into a single variable to get ourselves a continuous variable measuring organizational commitment. Next, your independent variable should consist of 3 or more categorical independent groups. In this case, we've got junior, middle and senior. Assumption number 3, you should have independence of observation, which means there is no relationship between the observations in each group or between the groups themselves. For example, there must be different participants in each group with no participants being in more than one group. Obviously, the people in the junior rank did not answer about organizational commitment in the middle rank because they are in the junior rank. So each of the group had their own individual respondent. Assumption number 4, there are no significant outliers. So your data is to a certain extent normally distributed. This is your assumption number 5. For each category, for junior, middle and senior level employees, your organizational commitment in each of these categories is normally distributed. For example, your skewness and kurtosis score in each of the categories should be within the range of +2 -2 or ±10 for kurtosis. So how do you check for outliers? We are going to discuss this as well. Assumption number 6. There needs to be homogeneity of variance. That is, we will run Levene's test of equality of variance to test for homogeneity of variance. You can test this assumption in SPSS using Levene's test for homogeneity of variance. If the data fails this assumption, you will need not only carry out a Welch ANOVA instead of one-way ANOVA. You can do this using SPSS statistics, but also use a different post-hoc test. So you will use Welch ANOVA if your homogeneity of variance assumption is not met, that is, there are significant differences in the variances across the groups. And you will use a different post-hoc comparison. We are going to practically look into all these assumptions. So how do we check for outliers? In order to check for outliers, go to Analyze, Descriptive Statistics and Explore. From here, we will select organizational commitment and put it into dependent list. And from statistics, select outliers, press continue and press OK. Look at this. Are there any significant outliers? Now, how would I know if there are any significant outliers? Because they will be marked with an asterisk. There will be an asterisk with these numbers. These numbers show the row number for a particular response. If there is an asterisk with this number which shows the row number for the data, where is this row number? Here is this row number. Look at this. These are the row numbers. Now, if there is a star with it, then that means this outlier is significant and this row shall be deleted, or this particular data shall be removed. In this case, there are no significant outliers. Now, the next thing is, let's look for normality for each group. Now, how do we check for normality for each group? So, go to Data and Split File. Organize output by groups. And what is your grouping variable in this case? Rank. So, you put in rank here and press OK. Now, what you need to do is, how do we check normality? We go to Analyze, Descriptive Statistics and Descriptives. Which is the variable for which you want to assess the normality? The normality is assessed for your dependent variable. So, you put in the variable here. Go to Options and make sure Skewness and Kurtosis is selected, because this is we use for normality assessment. Press OK. And now look at this. We've got normality for junior, we have got normality for middle, we have got normality for senior. Now look at this. Within the range, within the range, within the range. Your skewness and kurtosis for each of your categories for your dependent variable is within the range of the values that are required for skewness and kurtosis. This means you can assume normality. Using one-way ANOVA. Now, how do you run one-way ANOVA? Here is our sample data. Here is our variable organizational commitment. And here is our categorical variable job rank. Now, in order to run this test, what you need to do is you need to go to Analyze, Compare Means, One-Way ANOVA. So, where is your dependent variable? Here is your dependent variable. Organizational commitment will get into dependent list. Your job rank will come into factor list. This is your grouping variable. Now look at the options. Your descriptive statistics, your homogeneity of variance and your Welch test. Why do we need Welch? Because if the homogeneity of variance test fails. So what you need to do is you need to press continue, and for now just press OK. Descriptive. You had 90 junior level employees, 206 middle level and 45 senior level employees. And this is the mean score in each of these categories for your organizational commitment. Now coming back to our ANOVA results. Is your test of homogeneity of variance significant? Based on the mean, it is significant. Your assumption of homogeneity of variance is violated. There is no equal variance across the three groups because this value is less than 0.05. Now, if it is less than 0.05, your homogeneity of variance is significant. That is, the three groups have unequal variance. If they have got unequal variance, the assumption of variance is not satisfied. Now, once it is not satisfied, what will you do? You will not use this ANOVA table. You will use robust test for equality of means, and you will see the significance here instead of this particular significance. If this would have been insignificant, then we would have said equal variance assumed, then we would have used this table. Now what do I mean by using this table or this table? Now when I say I'm using this table or this ANOVA table and this significance value, this means overall there are significant differences in organizational commitment across the three job ranks. In this case, I'm using this table because your homogeneity of variance is significant. So what do we mean by this significance here? What is meant by this? Accordingly, this significance means there are significant differences in organizational commitment across the three job ranks. That is, the organizational commitment differs across the three job ranks. In this case, your null hypothesis is rejected. What was your null hypothesis? Here it is. Now this one's rejected. There are differences. How do I know there are differences? Because this here is significant. Now if there are differences, we need to do multiple comparisons. What sort of comparisons? These sort of comparisons. Are there differences between junior middle, middle senior or junior senior? I do not yet know based on this particular significance that whether the differences between the groups are significant or not, because this is conveying or giving me an overall picture rather than the differences between specific groups. Now I want to find out the differences between specific groups, because right now I've just tested these hypotheses. That's it. Overall differences in organizational commitment across the job rank. Now I want to test specific differences. So where are my specific differences? Now the next step is to assess these individual differences between the groups. Now before we test these differences, make sure that you go to split file and remove this rank and analyze all the cases. So go to analyze, compare means, one-way ANOVA, and go to post-hoc for individual comparison. In this case, equal variance was not assumed. Why? Because if you look here, this was significant. So equal variance not assumed. Go to post-hoc. Which one will you select? You can select done it, that is normally used, and press continue, press OK, and now look at this table here. Now this table actually now provides us with details of individual comparison between groups. The comparison of junior with middle, insignificant. So there is no significant or there are no significant differences in organizational commitment between junior and middle rank employees. Why am I saying that there are no differences in organizational commitment between junior and middle? Because this p-value is greater than 0.05. But look at this, junior and senior. The organizational commitment between junior and senior level employees is significantly different from each other. Why is it significantly different? Because the p-value is less than 0.05. Similarly, you can evaluate the rest of them. Obviously, this last one is just the repetition of the previous ones. Make sure you have just or you follow your hypothesis and interpret your results. In order to report one-way ANOVA, what you can do is, the problem is to investigate organizational commitment and whether or not it differs between different levels within the organization, junior, middle and senior. So your hypothesis, there are significant differences in organizational commitment across the management levels. First thing, we will explain overall results, your F statistic, your p-value. And once you explain or write about the overall comparison that yes, there are significant differences across the three job levels, you can do your multiple comparisons for each of the individual groups. Like the test indicated the mean score for junior level employees was significantly different from senior level employees. So now these are individual comparisons between different level of employees. And finally, you can make up a table like this, that is mean values, their standard deviation and your overall results. So overall there are significant differences. The mean statistic, significance value. Since in this case we have used Welch, so you can change this F statistic with this statistics here, this value, this statistic 14.744. So what you can do is, instead of 14.744, so you can write Welch statistic, and similarly you can change it here. .744. The rest obviously remains the same. So where are these 95% confidence interval and where are these results? If you come here, look at this table, these are your multiple comparison table. And this is how you interpret your one-way ANOVA. Thank you very much.